last lecture we have discussed about the radioactivity and the characteristic of alpha, beta, and gamma radiations. Now we see the units of measurement of radioactivity. कोई भी चीज हम किसी यूनिट्स द्वारा डिनोटेड करते हैं। आपको कुछ वेट्स लेना है, वॉल्यूम मेजर करना है, लेंथ नापनी है, या जो भी कुछ आप करना चाहते हैं। So typically we are using a different units of different systems. So radiations measurement के लिए हम भी अलग-अलग प्रकार के equipments, instruments use करते हैं. But radioactivity or the radiations we are measured by using units that's called curie. That's denoted by C or CI. Small c or CI. Some places the CI is used as the unit of curie. A curie, particularly that's we are saying, it is the quantity of radioactive substance undergoing 3.7 into 10 raised to 10 disintegration first. That's the definition of curie. Curie means it is the quantity of radioactivity. It is the quantity of radioactivity of radioactive substance undergoing 3.7 into 10 raised to 10 disintegration per second. So that's the unit definition of curie. It is the quantity of radioactive substance undergoing 3.7 into 10 raised to 10 disintegration per second. And this is a large unit, and actual practice in the following of sub-units of Curie are used. So it is the large unit of measurement of radiations, and sub-units, these small units are used. That's we are saying as follows. Second, millicurie. Millicurie. That's we are denoted by MC. Is 1 MC is equal to 1 into 10 raised to minus 3 curie. That we are saying. It undergoes 3.7 into 10 raised to 7 disintegration per unit. Then microcurie. That's also we are saying MC and micro, small in capital A. That's we are saying 1 MC is equal to 1 into 10 raised to minus 6. Then becquerel, one more unit, BECQU UEREL, becquerel. That's denoted by BQ. One BQ is equal to 2.7 into 10 raised to minus 11 P. Then electron volt EV, 1 EV is equal to 1.60 into 10 raised to minus 19 Curie. Sorry, not Curie, they are joules. 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 The next unit, that's voltage and electron volt. That's the ionizing radiation is form of energy and the unit of measurement is the electron. What we say? Electron volt and India. Ionizing radiation is a form of energy. Definition. Ionizing radiation is a form of energy and the unit of measurement of this is electron volt. It is kinetic energy, kinetic energy acquired by an electron acquired by an electron when it is accelerated through a potential difference through a potential difference of 1 volt. It is the smallest unit. 1 EV is equal to 1.60 into 10 raised to 19 joules. Then another unit, that the units of exposure, absorbed dose and dose quantities are as follows. तो यहाँ ये जो है Curie is the main unit of the measurement of radiation, and millicurie, microcurie, becquerel are the smallest units of Curie. Electron volt, That is also smallest unit. Particularly, that's where I'm saying it is the kinetic energy acquired by an electron when it is accelerated through a potential difference of 1 volt. That's simple. Ionizing radiation is a form of energy, and the unit measurement of this is called as electron volt. Okay. Now, the units used for the exposure or the absorb dose of radioactivity, यानी जब आप डोसेस देते हैं रेडिएशंस के, तो वो जो है वो किस नाम से या किस साइन से जो है वो जाने जाते हैं या पहचाने जाते हैं. The units of exposure or absorb dose and dose equivalents are as follows. First, Rontagen. It is the unit of exposure. It is the unit of exposure. 1 R, that is denoted by R. 1 R is equal to 2.58 into 10 raised to minus 4 CKG minus 1. Here C is equal to Coulomb. 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 The next, that is the rad. It is the unit of absorbed dose. It is the unit of absorbed dose. That means this one. Nitrogen, that's the units of exposure. So 1 rad is equal to 10 raised to minus 2 JkG minus 1. Then rem. The red equivalent man. Red equivalent man. That's a long form of red. It refers the unit of dose equivalents. It refers the unit of dose equivalents. Dose in rem is equal to dose in rad into quality factor quality factor into distribution factor. So that's why I saying that those in red. Those in red into quality factor into distribution factor. Red means unit of absorbed. So absorbed dose into quality factor into distribution factor, that's equal to the dose in red. Red equivalent man. And last one, that's exposure constant. Exposure constant. Exposure constant means that also we are saying exposure rate constant. It refers to the dose rate in Röntgen. It refers to dose in Röntgen. This one, Röntgen. 1 R is equal to 2.58 into 10 raised to minus 4 CKG minus 1. That is the rate unit of exposure. So exposure rate constant. It refers the dose in Röntgen per hour at 1 meter distance. Per hour at 1 meter distance from one curie. So that's we are saying the exposure rate constant. It is about 1/10 the dose at a distance of 1 foot from one curie. अगर 1 फुट से 1 क्यूरी का जो भी कुछ डिस्टेंस होगा उसके ऊपर से जो रेडिएशन देते हैं उसके 1/10 होगा 1 मीटर के ऊपर से. ओके. So these are the various units used in the radioactivity. Okay. Now, biological effects of radiation. That is the most important part that we see in short. Biological effects of radiation. ये radiations अगर हमारे शरीर के ऊपर टकराते हैं, शरीर से टकराते हैं, तो डेफिनेटली वो सेल्स में एब्जॉर्ब होंगे और जब सेल्स में एब्जॉर्ब होंगे तो उसका कुछ ना कुछ रिएक्शंस तो होगा ही. बायोलॉजिकल इफेक्ट्स ऑफ रेडिएशन. रेडिएशंस की इफेक्ट आपने स्कूल्स लाइफ में पढ़ा होगा, हिस्ट्री में पढ़ा होगा, जहां जहां पे रेडिएशंस एक्सपोज होते हैं लोग, तो वहां पर किस तरह की हालत होती है. हिरोशिमा एंड नागासाकी इज द बेस्ट एग्जांपल of the largest exposure of peoples with radiation. जब हिरोशिमा और नागासाकी में जब लिटिल फैट बॉय इस नाम का बम अमेरिका ने गिराया, तो ये एटम बम थे, ये जैसे फटे तो बहुत जबरदस्त एनर्जी प्रोड्यूस हुआ और रेडिएशंस प्रोड्यूस हुआ. also the peoples surrounding that area, staying in that area at that time, they are suffering. Not only they suffer, but their next generation also suffers. And that's due to that biological effects of radiation. Biological effects of radiations make any radiations particularly क्या इफेक्ट्स प्रोड्यूस करते हैं? Yes, radiations have dangerous effects on biological system. Locally induced ionization promotes the number of irreversible changes in living cells. जैसे वो सेल्स के ऊपर अटैक करता है या सेल्स के ऊपर उसके एब्जॉर्ब सेल्स में उसका एब्जॉर्प्शन होता है, तो बहुत सारे इरिवर्सिबल चेंजेस जो है वो, and these changes can be noticed after a short period of time, sometimes that requires few hours or days, or sometimes may take the years to develop also. Not only all that things, but sometimes in case of genetic changes, the effect can be seen in the subsequent or next generation also. मैंने अभी आपको बताया कि उस समय जो लोग रहते थे वहां पर उस एरिया में वो तो सफर हुए ही हुए, लेकिन उनकी आने वाली जो नेक्स्ट जनरेशन है वो भी सफर. The effect can be subsequent, seen in the subsequent or the next generation also. It must be assumed that all effects of radiation on living cells are harmful and there is no threshold level for the onset of their effect. वहाँ कोई लेवल नहीं है उसको मेजर करने के लिए इतने सीवियर इफेक्ट जो है रेडिएशंस द्वारा प्रोड्यूस होते हैं ह्यूमन सेल्स के ऊपर. The extent of harm is directly related to its interaction with the molecules present in the tissue to produce abnormal amount of ions and or free radicals. These chemical entities can alter the local pH, initiate a free radical chain mechanism leading to the formation of peroxides and other toxic substances. Simple. जब सेल्स के ऊपर, जैसे अगर आप इस सेल को कहते हैं तो सेल्स में तो बहुत कुछ होता है, जब रेडिएशन उसके ऊपर अटैक करता है तो इस सेल्स में इरिवर्सिबल चेंजेस जो है वो शुरू होते हैं, रिएक्शन जो है वो शुरू होते हैं. एंड व्हाट आर द मटेरियल प्रेजेंट विद इन दैट सेल दैट स्टार्ट्स टू आयनाइज. अब इमेजिन कीजिए कि वहां पर जितने भी प्रोटीन्स, अमीनो एसिड्स, कार्बोहाइड्रेट्स, लिपिड्स, जो भी कुछ मटेरियल होगा दैट स्टार्ट्स टू आयनाइज. Wani, water that also starts to ionize, and we have taken that example of water and how that water produces peroxides, and that peroxides how that produces that toxic substance that we see one by one here. So that's the effects of radiations. That biological effect of radiation depends upon the following factors like energy of radiation, factors on which that effects depends. First one, particularly we say that energy of radiation, energy of radiation, particular tissue being affected, surface area of tissue exposed, being exposed, dose rate of radiation. These are the factors on which that effects can be depends. Generally, it is assumed that the effect of radiation on tissue is harmful. The interaction of radiation with molecules of tissue forms chemical species or radicals which initiates free radical mechanism leading to the absorption or formation of toxic compounds which can destroy the organs or cell tissue. For example, water में responded as under अगर पानी जैसे मैंने भी आपको बताया कि हम सिंपल एग्जांपल्स लेते हैं वाटर वाटर जो है सिलिंडर fluid that how affect and produces that chain propagation and chain termination reaction. H2O radiation particles that produces H plus OH minus. That's the chain initiation. We say यहाँ से शुरुआत होगी आयोनाइजेशन दैट रेडिएशंस क्या करेंगे इसको आयोनाइज करेंगे हाइड्रोजन एंड हाइड्रोक्सी ions can be produced. Now what happens? This produces H2 plus OH. That produces H2O2 plus H. That's we are saying chain propagation reaction. आयोनाइज होने के बाद में क्या करेगा यही रिएक्ट होगा हाइड्रोजन भी प्रोड्यूस करेगा हाइड्रोक्सिल आयंस भी प्रोड्यूस करेगा अब ये हाइड्रोक्सिल आयंस यहाँ रिएक्ट होंगे तो ये हाइड्रोजन पेरोक्साइड फॉर्म करेगा हाइड्रोजन प्रोड्यूस अब दिस हाइड्रोजन peroxide H2O2 all of you know that it is an antioxidant antimicrobials so that produces again peroxides which destroys that cells so that's further chain termination reaction is occurs. That's we are saying chain termination reaction. अब ये जो चेन टर्मिनेशन रिएक्शंस होंगे चेन टर्मिनेशन जो शुरुआत करेंगे ये टर्मिनेट करके अब इस यहाँ पर आ गए but these hydrogen peroxide produces by that peroxide destroys the function of cells and that cells becomes dead. The free radicals which are produced that form peroxides and other toxic compounds. These are the effects of radiation. Okay? ये रिएक्शंस होगा और इस रिएक्शंस के द्वारा जो लिपिड्स प्रोड्यूस होने वाले हैं दैट्स वी सी वन on the effects first effect. Particularly we see that the free radicals is H and OH of water forms peroxide and other toxic compounds. The second effect, it affects the DNA of the cells, affects DNA in the cell. It causes cross-linking of amino acid. Amino acid. Affected tissue gets destroyed. Alpha particle produces free radicals which have a small range so they are kept close to the object to see the effect. Gamma radiation have high range. High range. So the source is kept at the distance of several meters. Several meters from the tissue as it may damage the damage to the tissue. So these are the various effects. Not only are these effects, but the bone marrow, mucosa of the gut, fetus, gonads, etc. are easily affected by the radiations. High energy radiation can affect skin and other tissues. Irradiation, sickness, nausea, vomiting, etc. are the effects of radiation. The most common uncomforted felt seriously affect the internal organs. Like that, various side effects can be produced due to the radiations. So radiations mainly we are saying destroys the cell, and in the treatment of cancer, the targeted that cancer cells for by the radiation and destroy that cancer cells. So by this way that use in the treatment of cancer. So these are the various effects of radiations. Thank you.